Okay, so I think you did pretty well. Didn't get the last step. This is about as far as I saw some of you, but I think you got it. Yeah, I think you got it. Okay? But let's be sure we be careful about the rules, because there are ways that you could still mess this up. Okay? So we got this because, of course, we already had it, but I think you understand it. And then all we got to do is see that, well, we have a constant here. No constant comes out of the whole thing. We're still going to have a c from this. But then we're going to have a c, negative c cosine of ct prime. So it's going to be negative c times, actually I'm going to write it like this. It's going to be c times negative c sine of ct. And you might have skipped this intermediate step and just written down negative c squared sine of ct. So that's how we could get c squared sine of ct from the second derivative. How do we adapt this if what we want to get this? Well, this is just like this, except that we got a negative k over m here and we got a c squared here, right? So this should be just like this, except what do we have to use instead of c?
Square root of k over m.
Good. Square root of k over m. Okay? So, we can conclude that we have solutions to this. Okay? And you can also verify easily that this is a solution. Now this is really, this square root of k over m thing is maybe one of the last things that we actually do in the chapter, in the text, in the semester, and everybody forgets it. Nobody knows what it means, which is why I'm starting the course with it. I'm determined that I will teach at least one class in my life where people understand this. Okay? People don't understand it. They memorize the formula, but they don't know what it means, so they can't use it. Except very trivial problems. Okay? And it's one of the hard things in the course. The reason it's hard is people don't understand it. But that's the result. So we use omega. And you've already seen omega, right? In SI units, it's measured in radians per second. So if you know the value of K and you know the mass in SI units, you can easily tell how fast a beam would be traveling, rotating. If it was a beam, now this isn't a beam, it's an oscillating object, but we'll see how that works next time. Okay? Now, One more comment. This is a solution, and it's the only possible solution. I say it's the only possible solution. Except this is also a possible solution. Because you have a formula for the sine of the sum of two things. It's in terms of the sine and the cosine from trigonometry. And you can relate this to this. Okay? So this is just another way of writing this. And we'll talk a little bit about the trigonometry. And if you understand all the mathematics that's implicit in what we've done here, calculus at least to the depth of being able to do this, okay? And then be able to do it with other functions, basic derivatives, nothing tricky. And a little bit of trigonometry, basic trigonometry, sum of two angles formula, stuff like that. Then you have all the mathematics you need for the course. If you don't know it right off the top of your head, that's not a problem. If you don't know it after a reasonable time of review, then it is a problem, okay? I don't think it's going to be a problem for most of you who've had calculus. Given the work habits I've seen and given the quality of the work you guys turned in last week, I think we're going to be good. And Dakota, this is just stuff you can plug into a calculator, okay? So at this point, we skip the no more calculus. The calculus is just a brief interlude. We get this conclusion. Actually, there's another thing, but you're going to do that for homework, except you won't have to. Because you won't have to do the calculus. Switch you to a different course. Okay? Stay in here. Make sure that's what you really want to do. But then, just learn the stuff that isn't the calculus. And you might not have had trig. So, you won't know the trig. It will put you in the course. It allows you to just focus on the non-calculus, non-trig stuff. Okay?